Now let's understand what is interpreted versus compiled languages. In interpreted languages like Node.js or Python, for our application to be understood in your runtime environment, for our application to be run, it needs to be understood by the system. So in Python and Node.js applications, for the system to understand your application, so it runs it, it must understand the language of your application. For example, if you want to run the application that is Node.js, your system or your runtime environment also must understand Node.js as a language. If it is Python, it would be the same. Your runtime environment must understand Python. Whereas in compilation or compiled languages, it is not like that. In compilation, your application is compiled into a single binary. So the application is only understood in the primitive level, that is the binary language, that is zeros and ones. Instead of needing a specific language, Node, Python, C, etc. languages, it only understands application on zeros and ones, that is binary language or machine code or byte code, which means the application image size in the compilation languages is smaller compared to interpreted languages. Let's understand it deeper. Execution model in Node.js, Python or interpreted languages. Source code is read and executed directly by a runtime Node.js engine or Python interpreter. Whereas in compilation languages, that is Go, Rust, Java, WSM, source code is transformed into a binary machine code or bytecode before execution. Runtime dependency. Interpreted languages needs the language runtime inside the container, that is Node Python, whereas in compiled languages, because binary is self-contained, runtime may be optional. For Go or Rust, runtime dependencies are not needed, is required only for Java, that is Java Virtual Machine. Dockerfile builder stage. In interpreted Node.js or Python, mostly installs dependencies, npm install, pip install, no heavy compilation step. Whereas in compiled languages, it compiles into an artifact, that is Go build, cargo build, MVN package. Interpreted languages doesn't have heavy compilation step, because we already have an interpreter or engine that understands your application's language, so it doesn't need much of a compilation, as the application is run by the interpreter or is understood by the interpreter. Whereas compiled languages, the application must be compiled first and then the application would be converted into the binary language, and that must be understood by the binary language in the zeros and ones. So it first needs compilation, then to be understood it is converted into the zeros and ones in the binary language. So it requires compilation first in the compiled, whereas it is not required in the interpreter. Dockerfile runtime stage. Interpreter must include the runtime image Node 18 Slim or Python 18, Python 3.11 Slim. Whereas in compiled languages, it is often just Scratch or minimal base, that is Debian Slim with the binary. In interpreter languages, we must be using or we must include runtime image, or we must specify the runtime image. In Node.js, we must specify the Node 18 Slim, or in Python 3.11 Slim, or whatever image we are using. Whereas in compiled languages, we don't need that. In compiled languages, the runtime image can be Scratch, that is just empty. Scratch means nothing, it is empty. Or it can be minimal base Debian Slim, which makes the compiled languages or image size of the compiled languages a lot smaller and lightweight compared to the interpreted languages. Docker image. Output artifact. App code plus dependency folder, that is node underscore modules, Python env. In compiled, that is single binary or package artifact, that is name app.jar, app.wsm. This is what I've explained. before. Interpreted languages has certain folders, that is node modules for node that has dependencies, Python env that has Python environments. We have those in the Python and node because it is an interpreted languages, and that interpreter can understand the node folders without compilation, as it understands the language of your code because the runtime must be your application languages. Whereas in compiled languages, the application or the code is first compiled a single binary or a single packaged artifact, that is main or app.jar or app.wsm, because when that app in the compiled languages is in a single packaged format, then only it can be compiled into the binary or machine code. So the application is compiled into a single artifact, then that single artifact is transformed into a binary, machine code or byte code before its execution. Image size in interpreted languages is larger because of the runtime plus dependencies that are must, whereas in compiled languages image size is smaller because only binary is shipped. Portability. Interpreted languages needs runtime installed wherever it runs, whereas in compiled languages, binary can run anywhere with compatible operating system or CPU or WSI host for WSM. As mentioned, Node.js, Python are interpreted languages that needs a runtime that understand its language, whereas in compiled applications that run on compiled understands only the binary or machine code or byte code, so it can be run anywhere with a compatible operating system or the CPU that supports or WSI host for WSM. So why this matters in Docker files? Node or Python, Docker files always copy both code and dependencies, then rely on the runtime image to execute. Go, Rust, WSM. Docker files focus on producing a binary in the builder stage, then ship only that binary into a minimum runtime image. In Java, compile to, but instead of native binary, it produces byte code jar that still requires the JVM runtime, AIML or Python. Even though Python is interpreted, the runtime image is heavy because it must include CUDA libraries and machine learning frameworks. That was about compilation versus interpreted languages.